The birth and death of a star in Andromeda. More than 2.5 million years ago, deep in the Andromeda Galaxy, a massive star near the galactic parent ended its life. When the nuclear fuel runs out, the star cannot withstand the high pressure in its core, causing a catastrophic supernova. The explosion released unimaginable energy and threw millions of tons of red-hot plasma into space. Planets and nearby moons rotate around their parent star and are constantly sprayed with cosmic dust. The dying star also released electromagnetic waves, shock waves that travel around the universe at the speed of light. This pulse, which takes millions of years to travel the great distances of space, reaches a small and distant world, Earth. But for now, the explosion will remain a celestial sight, its light fading into the background of the galaxy as it continues, the flame of 1885. Fast forward to 1885 on Earth. The scientific community was fascinated by an astronomical phenomenon. A bright flare appeared in the Andromeda Nebula, outshining nearby stars in its immense brightness. This supernova, later known as SN 1885A or S Andromeda, has puzzled astronomers for years because of its unusual properties. Unlike other supernovae that are visible for a long time, S Andromeda darkens quickly and disappears from the night sky in about 6 months. At that time, world knowledge was still in its infancy. Astronomers have not yet developed the necessary instruments to measure the great distances between celestial bodies. As a result, the Andromeda Nebula was mistaken for a reflection nebula near the Milky Way. Little did they know that they were witnessing an event in a completely different galaxy, one beyond our borders, the Andromeda Galaxy, a great spiral. The Andromeda Nebula was first discovered in the 1920s. Thanks to the work of astronomers such as Edwin Hubble, it became clear that Andromeda is not just a mirror nebula, but a spiral galaxy, much like the Milky Way. This discovery was groundbreaking because it expanded the known universe and included the concept of galaxies beyond our own. Today we know that the Andromeda Galaxy, also known as M31, is a diffuse spiral galaxy containing about 1 trillion stars. At over 150,000 light-years in diameter, Andromeda is one of the largest galaxies in our local group. The mass, estimated to be between 800 billion and 1.2 trillion solar masses, is about the same as the mass of the Milky Way. However, Andromeda has a unique composition with an abundance of red dwarf stars and a low concentration of dark matter. At the center of this beautiful galaxy lies a massive core, a dense collection of stars so densely packed that it emits a blinding glow. This intense brightness has long made it difficult to study the individual stars in the core, obscuring the remnants of the 1885 S Andromeda supernova. For more than a century, the exact location of this supernova will be obscured by the blinding light of the galactic core. Discovery of the remains of S Andromeda in 1988, more than a century after the flare, astronomers discovered a small nebula near the heart of Andromeda. This dark spot, invisible against the bright background, was identified as the remnant of SN 1885A. Spatial analysis and precise motion modeling confirmed its identity and indicated that it was the first supernova remnant discovered outside the Milky Way. The study of Andromeda's core has shown that it differs from other spiral galaxies. Most importantly, Andromeda's core appears to be a double core, a feature that has surprised scientists. The brighter and larger part of this binary core is slightly distant from the geometric center of the galaxy and contains a star cluster 7 light-years away. The second faintest part is closer to the center and has a diameter of 1.3 light-years. This region is believed to contain a supermassive black hole, estimated to be 50 million times the mass of our Sun. The origin of Andromeda's binary core remains a subject of scientific debate. Some theories suggest that Andromeda may have been part of a large satellite galaxy in the past, with the bright spot reflecting the remnants of its parent. Some believe it is a single core structure, but it is covered by a band of opaque dust that creates the optical illusion of a double core. Despite ongoing research, the true nature of Andromeda's core remains a mystery, due to the galaxy's remote location and the challenges of observing it from Earth. Mysterious low-mass binary. As we peer deeper into the heart of the Andromeda Galaxy, we encounter one of its most mysterious objects, a low-mass binary X-ray and tongue twist. The name of this celestial body in the near-optical spectrum is invisible even to the most powerful telescopes. But when seen in the X-ray spectrum, it becomes the brightest point in the galaxy. This low-mass X-ray binary is a two-part binary star system. The first star was a neutron star, the densest remnant of a supernova, with a radius of only 10 kilometers. This neutron star rotates rapidly, rotating on its axis approximately every 3 seconds. Another star in the system is more massive but fainter, possibly a red giant. Calculations show that the combined mass of the two stars is no more than 3 solar masses, and the distance between them is very small. Every 4 hours, the neutron star is captured by its companion, and its brightness decreases significantly before returning. Due to the close proximity of the stars, the neutron star gathers material into the red giant, increasing its mass over time. This process is expected to continue for tens of millions of years, and eventually the second star will collapse, be torn apart by tidal waves, and form a hot ring nebula. The complex structure of Andromeda's central region. As we explore Andromeda's central region, we discover that this galaxy is home to many wonders and mysteries. The stars near the core are crowded together, forming a giant bulge about 12,000 light-years across. This elongated bulge contains 30% of the entire mass of the Andromeda Galaxy. Andromeda also has a unique bar structure, although it can't be seen by observers on Earth because its narrow side faces us. The length of this belt is estimated to be 17,700 light-years, and the width is 6,200 light-years. It forms the base of the two giant spiral arms that spiral around the center of the galaxy. These spiral arms contain 56% of Andromeda's stellar mass, in addition to a large amount of dark matter. The force of these arms gathers interstellar gas and dust, creating stellar nurseries where new stars are born. Over time, these regions grow into open clusters and connections, with young stars illuminating the surrounding cosmic dust and giving the galactic disk a brilliant palette of colors. A.e. Andromeda, the blue moon array. Among the many stars in the Andromeda Galaxy, one stands out the most, A.e. Andromeda. The star is a blue variable star, a rare and unstable type of star known for its sudden brightness. A.e. Andromeda is a very warm blue, and the brightness varies greatly with no apparent pattern. The outer layers of A.e. Andromeda are in a state of unstable equilibrium, with chaotic and unpredictable actions within. Streams of fiery plasma sometimes collide and create flares that can increase a star's brightness tenfold. In extreme cases, a phenomenon known as a decoy supernova occurs, where the star's brightness briefly increases by millions of times. Despite its rarity, A.e. Andromeda is a massive star, estimated to be between 50 and 120 solar masses. Its radius, at maximum, is about 55 times that of our Sun. About the size of Mercury's orbit. The star's surface temperature is about 20,000 K, and its luminosity is 500,000 to 700,000 times that of the Sun. Like all blue giants, A.e. Andromeda produces strong stellar winds that can reach speeds of up to 1,000 km per second. This gas causes the star to lose about 2 to 4 billion tons of matter per second. Despite this large loss, the size of A.e. Andromeda means that these losses are almost invisible. However, A.e. Andromeda has expired. Although the star is only 2 million years old, very young by cosmic standards, the star has already completed most of its life cycle. In the next million years, A.e. Andromeda is predicted to go supernova, leaving behind a black hole surrounded by a large nebula of gas and dust. Charting Andromeda's formation history. The distribution of stars in the Andromeda Galaxy reveals its formation history. The oldest stars, formed about 11 billion years ago, are found in the galactic bulge, while the youngest stars are found in spiral arms, formed in clusters and relationship over the past million years. Apart from its large spiral arms, Andromeda has a very thin disk, only 3,000 light-years thick. Making up about 10% of the galaxy's mass, this disk is home to a complex network of globular clusters, dwarf galaxies and other objects. Over the past billion years, Andromeda has swallowed several smaller galaxies, adding mass and changing its composition. These mergers created a series of tidal paths and star streams visible from the edge of the galaxy. These formations reflect Andromeda's past and its ongoing evolution. The inevitable collision with the Milky Way galaxy. Andromeda's future is even more exciting than its past. In 4.5 billion years, the galaxy will collide with the Milky Way. When the two galaxies come close, their gravitational forces interact, forming a new galaxy, called Milkomeda. This collision is a slow and complex process that takes billions of years. In the beginning, the two galaxies pass each other, and most of the stars avoid the collision due to the great distance between them. However, when galaxies are disrupted by gravity, they lose their spiral arms and become more elliptical. As the galaxies merge, new regions of intense star formation will emerge, and the supermassive black holes at the centers of the Milky Way and Andromeda will eventually merge, creating an even larger black hole. Over time, the remnants of the galaxies will settle into a new, stable configuration, forming a massive elliptical galaxy. The Andromeda Galaxy, with its vast size and rich history, continues to captivate astronomers and inspire our understanding of the universe. From the mysterious flare of 1885 to the complex structure of its central region, Andromeda offers a glimpse into the dynamic processes that shape galaxies. As we look to the future, the impending collision with the Milky Way promises to be a cosmic event of unparalleled significance, reshaping our understanding of the universe and the forces that govern it.